So dear students, today we are going to discuss various means of the cooling of a transformer. Practically when you have installed a transformer, it may be of several MVA or several kVA. So when the transformer is operating in that rating range, then invariably the amount of heat emanated will be quite large. So there are various methods of cooling of transformers. We will discuss them out one by one. To begin with, the first one is air natural cooling. So air natural cooling, as the name suggests, natural air is used, and the heat of the core and the winding of the transformer is transferred to natural air by convection. Natural air cools off the core as well as the windings of the transformer, and hence such transformers are often referred as the self-cooled transformers, and the method therefore is called self-cooled method of cooling of transformers. And usually this particular type of cooling is a very primary type of cooling, very basic type of cooling, and hence the rating of transformers which use this particular type of cooling may be limited to 1.5 MVA. Now the next cooling type of cooling is air forced or air blast cooling. Once the heat emanated by the transformer becomes over a certain range, then self cooling may not be sufficient. So in this case, what we do is we direct a blow of air. And how do we create that blow of air? By use of fans and blowers. So fans and blowers continuously blow the cooling air towards the core of the transformer. They cool the transformer core and windings, and as a result the temperature is maintained within safe working limits. Okay, typically this type of cooling may be employed for transformers rated up to 15 MVA. Now once we so earlier two methods which we have discussed, they were for self-cooled or air-cooled type of transformers, or transformers which are as such not oil immersed transformers. Now insofar as cooling of oil immersed transformers is concerned, now we will discuss such methods one by one. So the first one is oil natural, air natural cooling. So if you see, there is a diagram which is shown over here. Core is shown, windings are shown, the two rectangular constructions on either sides of the transformer enclosure that you see over here, they are the transformer radiators, and one could easily see them in any of the transformers which are installed, distribution transformers, which we often witness while going somewhere along the roads. They are installed. So what happens is, when oil gets heated up, it expands and it enters these radiators, and it circulates through these radiator vents. Okay, so in these vents, obviously the surrounding air, this air works through the radiator tubes on the oil, it cools it, and this is how we maintain the temperature inside the transformer within safe working limit. So this type of cooling method is typically used for transformers rated up to 30 MVA. So as you will witness later on, that when we keep on going for higher and higher rating transformers, then we have to bring in certain degree of innovation in the methods which are employed for cooling. So theory is there, you can just go through it, but basic idea I have given you. So in this type of transformer, essentially natural air is used, and the oil which is heated up gets entered, or it enters into the radiators, and natural air works on the tubes of the natural or surrounding air in the vicinity of the radiators. So natural air works on the radiator tubes, and it cools off the oil, which again the cooled oil maintains temperature within safe working limit. Then oil natural air forced cooling. So as the name suggests, in this case we use blowers or fans are installed along the radiators, and instead of using natural air, here we blow the air through fans, and that forced air is essentially used to cool off the oil which is entering the radiator. Okay, so what happens is the oil from the conservator comes down, and the quantity of oil which has entered the radiator, that is replaced by cooled oil from the conservator. And again, once this cooled oil which entered earlier, because of the hot oil circulating through radiator, now that becomes heated up, and that enters the radiator from wherein it is cooled off, and this cycle keeps going on. So in this case, essentially the difference between the air natural and air forced is that here we are employing mechanical means for blowing air at a certain velocity. And if you see, the rating of transformers, it can be used up to 60 MVA. Again, as we are moving on to different methods, or from one method to another method, you must observe that the rating of transformers is correspondingly going up and up. Next is oil forced, air forced. So in this case, we don't have a simple sort of methodology for cooling as we had in earlier two cases, but here we employ pumps. We circulate the oil as well. So oil is pumped through oil pumps at the same time, and a heat exchanging unit is created at a certain distance from the transformer main tank. Conservator is installed above this heat exchanger unit. Oil is brought from the oil tank into the heat exchanger, where through the pumps, wherein through the action of fans, air is blown towards the heat exchanger, oil gets cooled up, and then it is recirculated into the transformer. So continuously what happens is, cool oil from the conservator enters the transformer tank, and heated oil is transferred to the heat exchanger, wherein it is cooled through the action of forced air, and then again it is recirculated towards the tank of the transformer. So this is how this cycle keeps going on or continues. Now till in the earlier method, as you have already observed, we have used either the transformer oil is circulated, and along with that air is used. So now we have come to a method wherein we will use water instead of air. So oil natural, water force type of transformers. So in these transformer, the oil is not circulated using any pump or any other mechanism. Instead of that, what we have is, we have radiators. You must have seen radiators in the DG sets, standalone DG sets, which we often use in our premises or at various commercial establishments. So therein a radiator is there. A radiator has we fill radiator with cool water, and air blows through this radiator and cools off the engine of the generator or DG set. So exactly in the same manner here, oil natural means oil is not forced, or rather what we have is water force. So cooling water is used in this method. The transformer core and the windings are immersed in oil tank. As it happens with a normal transformer, a radiator is installed outside the tank. So as I was mentioning to you, as the temperature rises and oil heats up and moves upward, the heat is dissipated by natural process of convection, and oil is passed through the radiator. Okay, so through the radiator, oil is passed. Radiator tubes consist of cooled water. In the process, water gets heated up because water acquires the heat of oil, and heated water is taken out. Then it is replaced with cool water. But in this process, oil gets cooled up, and again it goes towards the transformer tank. So this is how this particular system work. The next one is oil forced, water forced. So here, just like air force, oil forced, air force, instead of using blow of air, here we use we pump in water in the heat exchanger. Water acquires all the heat of the heated oil, cools it off, and then that oil is pumped back to the towards the tank of the transformer. So again, just like it was with air cooled oil forced, air forced transformers, here water is continuously pumped inside the heat exchanging unit. It's sort of a radiator, and hot water keeps coming out from the outlet, and cool water replaces it within the body of the heat exchanger or within the radiator, and in the process the oil is continuously cooled off. So cold oil is introduced inside the transformer tank, and heated oil continuously is forced inside the heat exchanging unit. Okay, so this is the one of the most efficient means of cooling of transformers, and it can be employed for transformers practically rated up to several hundred MVAs. So this was just about it, about the cooling of transformers. In the next session we will discuss about the induction motors.
स्टॉप कर दिया था हमने
ना